Good morning, everyone. Welcome to Introduction to Partial Discharge Test Diagnostics on HV Cables webinar. Let me introduce myself. I'm Lorenzo Paschini, Senior Service Engineer at Techim. And this webinar is going to take approximately 1 hour. So let's start. What is the summary of this webinar? We will have a short introduction to the partial discharge phenomena. We will see what are the sensor and instrument used for measuring partial discharge on high voltage cable. We will see what are the PD measurement solutions for high voltage cables. We will have a quick look at quality control and laboratory test. We will have a quite deep vision of the partial discharge test during the high voltage cable commissioning. We will see something about the online spot testing in high voltage cable. And we will see also the permanent PD monitoring solution. At the end, some of the case studies based on the experience we have on site, on real cases. So, in order to start, we can introduce the partial discharge as per the definition given by EAC. Partial discharge is a localized electrical discharge that only partially bridges the insulation between conductors, and which can or cannot occur adjacent to a conductor. The same definition given by the EEE is partial discharge is a localized electrical discharge that only partially bridges the insulation between conductors. Another important definition we need to have is the partial discharge pulse definition. As per the EAC, the partial discharge pulse is a current or voltage pulse that results from a partial discharge occurring within the object under test. The pulse is measured using suitable detector circuits, which can introduce into the test circuit for the purpose of the test. A similar definition given by IEEE is an high-frequency current or voltage pulse that results from a partial discharge. In a shielded power cable, the pulse propagates away from the PD source in both directions along the cable. Here we have, let's say, traditional PD pulse visualized with an oscilloscope. Analog one. And at the bottom, we have a more today technology with a digitalized pulse given by Techim instrumentation. Another very important concept for partial discharge testing is the phase-resolved partial discharge pattern, PRPD pattern. So each PD phenomena will generate thousands of PD pulses. Each defect will generate thousands of PD pulses each second. The common way to visualize them is to plot such pulses amplitude correlated with the applied voltage phase angle. The correlation is based on the PD physics. The electrical stress due to applied voltage activates partial discharge. The study of the PRPD pattern is the key for the recognition of the PD diagnostics outside of laboratories. As for the previous slides, we have, let's say, a traditional historic visualization of PRPD pattern with an ellipse method. And on the bottom, a more nowadays visualization of a phase-resolved PD pattern. Each point you can see in this graph is a PD pulse that is plotted on the vertical axis for its amplitude and on the horizontal axis for the phase angle of the applied voltage we are testing. The different colors are due to the different number of pulses recorded for that particular range of amplitude and phase angle. The red sine wave you can see is the reference of the applied voltage given to the instrument. Let's see what kind of partial discharge sources we can have in a high voltage cable. We can have voids in the cross-linked polyethylene, the insulation system. We can have interface gap between the semiconductor layer and the cross-linked polyethylene insulation system. We can have an interface gate on the inner side of the cross-linked polyethylene and the semiconductor layer. And we can have also inclusion of material or non-homogeneous status of the material itself. Nowadays, such kind of defect are not so common. The technology on the cable extrusion has widely enhanced its capabilities, and it's very rare to have problems in the cross-linked side of the cable system. even because all the cable drums are tested for partial discharge as end-of-line test. Other sources of the PD can be in the cable termination. We can have some cracks on the outside side of the insulator. We can have gas bubbles in the compound inside of the insulator. We can have also inclusion at the interface between the stress cone and the cable itself. We can have voids or cracks in the stress cone. In the joint, we can have crack and voids in the insulation body. We can have gas inclusion on the interface between the insulation body and the cable. We can also have gaps because of the misplacement between the electrode and the insulation body of the joints. Or we can have outer cuts on the semiconductor during the peeling stage of the joint. All of these defects can express themselves with partial discharge, and we are able to detect them thanks to the partial discharge analysis. So, main defect types, internal PD in the cable and its accessories. Surface PD on cable termination. Corroded shield problems. And broken jacket. Just to have a, let's say, visual inspection of what we are trying to find with partial discharge testing. Obviously, the harmfulness of the partial discharge is higher when we are in the middle of the insulation and lower when we are on the jacket side. So let's now go to the second, let's say, part of this webinar, where we are going to study the sensor instruments used for PD detection on high voltage cable. We will use coupling capacitor and measuring impedances. We will use high frequency current transformer. We will use embedded sensor in the high voltage cable accessories. And we can also have external sensor as flexible magnetic couplers and UHF antenna in some cases. After that, we will see also what instrument we can use. The KIMP has a wide portfolio of instrument for laboratory technologies instrument, for field testing instrument, and finally for permanent monitoring of the high voltage cables. Let's start with the coupling capacitor and measuring impedance. The coupling capacitor are mostly used in the laboratory. Those are the most sensitive sensor for partial discharge, and it's the first and most used technology in order to detect a partial discharge signal. The measuring impedance on the bottom of the coupling capacitor make the signal available for the detector. That is normally an oscilloscope-based instrument. The KIMP has a wide portfolio of measuring impedances and accessory to use with existing sensor and equipment in order to revamp each laboratory with the latest technologies available. The instrument you can see on the two coupling capacitor you can see on the left side, those are respectively on the top 100 kV coupling capacitor and on the bottom 50 kV coupling capacitor. On the right we have measuring impedance. Those can be customized to third-part coupling capacitor as well. PQ quadrupole is the commercial name for such device. High frequency current transformer, sensor used in the field testing on high voltage cables. We can clamp this sensor around the ground, the earthing leads of the termination and joints. It is possible to detect amplitude, shape, and polarity of the pulses flowing in the cable sheet. The KIMP has a wide range of diameters for such high frequency current transformer. They have been designed in order to reduce the low frequency signal. In that case, we can increase the signal to noise ratio. And from a very, let's say, site testing point of view, it's a very useful sensor because of its flexibility and because of the information that we have. The PD pulse with this high frequency current transformer brings to the testing engineer, to the testing team, a lot of information. Those can be very helpful for the diagnostics of the measuring session. We can install this HFCT on the grounding leads of the high voltage cable accessories, so cable and termination. We also have bigger sizes to clamp such sensor directly around the high voltage cable. We have a series of closed HFCT Those are used for permanent installation. And in any case, we have a wide selection of diameters and sizes for different utilizations. Some cable manufacturer can provide the accessories with embedded PD sensor. That's normally happening upon final customer specification, especially in the Gulf area. This is quite popular. Also in Terna, some of the 400 kV voltage connection, they have embedded PD sensor for detection. Typically, these sensors are capacitive, so they can provide to the testing engineer both PD signals and synchronization signal. They have a very high sensitivity and very high signal-to-noise ratio. Additionally, the quality of the waveform we acquired is almost perfect, since it's a direct coupling between the equipment under test and the instruments. In other technologies, I would say for Far East cable manufacturers, such sensors are more inductive, and we can have up to 4 sensors for each joint. We have basically an external folio of aluminum or copper wrapped around the semiconductor layer of the cable before and after the joint. Other sensors that we can use on site. These sensors are, let's say, external sensors. It can happen that in many cases we don't have embedded PD sensor because they are very rare. We do not have accessible ground leads, or due to safety, we cannot clamp our sensor on the accessible ground leads. And in such cases, we need something external that does not affect the normal, doesn't touch the hot parts of the cable. In this matter, the flexible magnetic coupler is very helpful. It can be wrapped around the voltage cable. It has a lower sensitivity compared to the previous sensors, but its flexibility for the installation gives to this sensor let's say, very, very high efficiency in some particular condition. Another sensor that we can use, especially on cable termination, when we want to, in GIS, where we have to understand some problems in the stress cones or similar upper parts of the termination, by using ultra high frequency antenna, we can pick up the irradiated signal of the PD to detect eventual PD sources in the GIS termination. Now we give a look at the laboratory instrument. The TECHIM solution for laboratory instrument is the PD-based 2. It is an ultra-wideband instrument, but has also the EAC 60270 narrow bandwidth mode. So we can perform both measurement in EAC bandwidth, narrow bandwidth, and ultra-wideband system. And it fits, let's say, the regulation for EAC 60270, giving chance to the user to take advantages of the ultra-wideband detection. Another instrument that is strictly required and strictly, let's say, standardized by EAC 60270 is the PD calibrator, because when we are in laboratory testing, we need to calibrate the measuring circuit by injecting a well-known charge and correlate this charge with the reading we are doing. We have an adjustable repetition rate of the PD pulses we can inject with the calibrator, and we have room light synchronization feature. So on the PRPD pattern, the PD calibrator pulse will be very visible compared to the background noise or other signals. For the field testing instrument, we need something more portable. We can lose the, let's say, specification for laboratories given by the EAC 60270. And the TECHIM portfolio present 2 big families of instruments. The Aquila and the related micro Aquila, those are PD detection units designed especially for field testing. They are battery based, they are ultra wideband system. They are equipped with time frequency map filtering tool patented by TECHIM and selectable acquisition functions. All the ultra wideband give us the chance to save much more data about the PD signals we are detecting, and applying some filtering tools like the time frequency mapping to the acquired data. In this case, we can get rid of unwanted signals and the background noise in order to increase the sensitivity of the measurement we are doing. It is both Aquila and Microaquila, they are battery equipped instruments. They can also work on automatic monitoring sessions, so they are able, given a time span between two different acquisitions, to automatically acquire data for a longer period that can be from a few hours up to a few days. The data will be then stored into the memory of the instrument itself and can be downloaded and studied at the end of the monitoring session by operators. The second instrument of the field test instrument family is the Alpha. What are the differences between Alpha and Aquila? Basically, Aquila and Microaquila, they are studied to be used by skilled personnel, and they have a variety of tuning parameters. Those can be set during the acquisition. In many cases, partial discharge can be a side activity for the testing engineers, something that they don't do every day, but just once in a while. And the Alpha takes care of this kind of customers and testing engineers by providing an automatic setup of the PD measurement chain, and automatically acquires PD data for the analysis. Just to give you an example, the Alpha has a step-by-step guide with a series of question and answer between the Alpha and the operator, like what are you testing? Do you have available ground leads or not? Is that current of the cable or not? And then gives the instruction to the user also for the sensor installation. And then you can launch an automatic acquisition. So even a not skilled operator or someone that doesn't want to learn too much about PD testing can perform a good acquisition with the Alpha unit. In the permanent monitoring system, we have, let's say, many detection points along the voltage cable. Those are called PD hubs. They are the core of the permanent monitoring systems. We have several of them distributed in the high voltage cable. Normally, one PD hub for each set of accessories. All these PD hubs are connected together via fiber optic, and all connected to a main server where all the data is stored, saved, and alarms are triggered in case of partial discharge events. We also have a temporary PD hub that is designed for spot testing and temporary monitoring. It is ideal for long cables for PD commissioning of long cables during the offline test. Our kit can cover a maximum of 45 detection points, and we can monitor 6 accessories with each PD hub. So once we have the temporary PD hubs in place and connected via fiber optic, we can perform a huge test in a few hours without, let's say, losing in sensitivity, and actually having a very good set of data in a very short time. So, if you want to resume a little bit, what is the PD test contribution to final customer? PD test basically should make asset managers' life easier. We have to reduce the risk of failure of the assets, to provide risk quantification, and to have a comparable index for the fleet health. We can basically take the normal failure rate and trying to fight each kind of failure with a different tool. We can, for example, pull down the failure risk at the beginning of the life of the asset by testing the cable during the commissioning with PD. We can reduce the random failures of the cable by doing some spot testing on permanent monitoring, and we can fight the wear out failures of the high voltage cable by permanent monitoring. So, in the first part of the life of the cable, we can do quality control and commissioning test. those will reduce the failure risk on the early life. We can perform online spot test and install permanent sensor to reduce the random risk failure. We can install a permanent monitoring system to fight the wear out failures of the high voltage cable. Now we have basically a description of the Tekim portfolio. When we talk about what we can have in different parts of the life. For quality control, the Tekim solution is PD based, that is a laboratory equipment and PD calibrator with a coupling capacitive sensor. For the commissioning test, we have a service solution for PD commissioning, and also we provide portable PD instrument and sensors. For operation and maintenance side of the life of the asset, we can perform online spot test as a service solution, or with a portable PD instrument that can be Aquila or Alpha and related sensor. Permanent sensor kit are very useful to, let's say, have a easier and the most effective way to test the cable during its lifetime. And it's also the first step to install a permanent monitoring system that will be a complete PD monitoring that 24/7 analyzes the PD data and triggers alarms in case of PD activities.